Well, hello. I'm going to do a talk. It's called Effective Code Review. But before we do anything about code review, I'm going to talk about cave diving. So when I'm not here doing tech stuff, I'm a scuba diver, and one of the things I do is cave diving. And it's good fun. You see, that picture is mainly of me. The caves are incredibly beautiful. I'm not so much. But one of the things we do in caves is I always dive in a team. There'll always be someone else with me at any one time. And it's great for many reasons. You know, we can talk about what an amazing cave dive it was afterwards. We can talk about all the fun things that we saw. So I've got to write my timings down. That's the whole point of this. We can, talk about all the amazing things we saw and so on. And the other great thing about diving with people is that if something goes wrong, they're there to help us out. So, if you had a catastrophic gas failure, you've got a buddy who's got some spare gas for you. If you have a light failure, you've got a buddy who's got a spare light. Now, all of those things have happened to me, and there's always been enough contingency in what I've taken that I've always been able to be self-sufficient to get out. But probably the most important thing that team members bring is a spare brain, because I have made mistakes, and those mistakes could have been fatal had someone not corrected them. So one of the things that makes cave diving safe is we always have a continuous line to the surface. So imagine this is a surface out here, and I'm going along looking at all these amazing caves, this stunning, beautiful cave, following a line, and eventually we get to a T-junction in the line. So we've got one line going one way and another line attached to it going off somewhere. And we might meet several T-junctions on a dive. So we need to remember where we came from. So we have this thing here, it's called a cookie. And what we do is we attach that to the line on the exit side. So I go off, leave it there on the exit side, I go off into the cave, look around, and then when I come back, I go, oh, that's my cookie, it's got my initials on. I know the exit's over there, and I pick it up. Pretty simple. I've told you that. You're probably never, ever going to make a mistake. And if you do make a mistake, let's say I'm going into the cave and I'm going off this way, and for whatever reason I put the cookie on the wrong line. I go off, I come back and I go, oh, the cookie's there. Obviously the exit's that way, but the exit isn't that way. I go further into the cave, run out of air and die. Now, given the consequences of making a mistake like that, and given how simple it is, you would think we would never make mistakes like that. Yeah, I've been on dives where mistakes like that have been made. And what happens if I'm going along, I put the cookie in the wrong place, my buddy will signal at me and say, stop, Dave, you put the cookie in the wrong place. And I go, oh yeah. So I have. I'll put it on the exit side, and then we'll get out alive instead of dying. So, what is the moral of this story? The moral of this story is we all make mistakes. Even when things like our lives depend on it, we still make mistakes. But also, if the mistakes are spotted and rectified quickly, the consequences of those mistakes are not that great. So when I put the cookie in the wrong place, my buddy points it out, I put it in the right place, we go on and we do the dive. And the consequences, I owe them a pint at the end for being an idiot. But if I put it in the wrong place and we didn't rectify it, then potentially bad things would happen. The other thing is we want it to be really obvious that we have made a mistake. So the cookie is really simple to see because I'm going along, I put it on the line, and immediately my buddy can see if I've done that correctly or not, and they can point out things if I've done it wrong. And you might say, well, what's this got to do with software development? And I would say in software development, it is, we all make mistakes. The sooner we rectify those mistakes, the less the bad consequences are, and we want to make our mistakes very easy to spot. And you've probably seen graphs like this, that generally the longer a bug festers in a system or the later it is found, the greater the cost it is in terms to fix it, and maybe the greater the cost there is in terms of reputational damage of a bug. And what we're kind of looking at today is what can we do to bring bugs from expensive, costly, down to cheap? How can we find them earlier? An effective code review is one of the things we can do. And essentially, if we do code review correctly, it reduces the overall cost of software development. So that's why we're here. It's a bit of a cost-cutting exercise. So who am I to tell you all about this? My name is David Liddament. I work for a company called Liddament Bristol. As I've already alluded to, I'm a scuba diver when I'm not doing PHP-related things. And I've been using code review on and off now for probably about 7 years, using various tools. And I think it's great. I couldn't imagine doing a project now without code review. It's a bit like testing was. Imagine you go on a project that doesn't have testing after you've been doing testing for ages. You just feel really uncomfortable, you know. And I feel the same about code review. So, this is what we're going to look at today. So we'll start with why. As we've kind of said before, it's the code review done well will reduce the overall cost of software development. So let's look at code quality. So code review on itself will help boost our code quality and therefore reduce the number of bugs we have in the system. But it's best done with other things. So really we get the most out of it if we also have tests, if we do some kind of analysis of the code, and if we have some kind of continuous integration. So that's something that when we push our code up, it goes off and automatically runs whatever it can do in terms of, it'll run all the tests for you, it'll run all the analysis on the code and report errors. So there's tools like Jenkins and Travis and Circle CI, which are continuous integration tools. And finally, a modern IDE. So if we've got like PHP Storm, which you can win a license if you give feedback. So all of these things together help get the most out of code review. So what is code review? Let's go to Wikipedia. Code review is the systematic examination of source code, and it is intended to find mistakes overlooked in software development, kind of improving the overall quality of the software. So we're looking at code, we're trying to find bugs, and we're reporting those bugs so that they're actioned and they are rectified earlier. Just like the cookie in the cave, the moment I made a mistake, let's point out where the mistake is, then we can just fix it, and it's easy fix. So how's code review done? There's kind of a couple of ways. I suppose there's they used to do it really formally, formal manner where people all come in a meeting and they'd all look at the code. But these days, I think the two main ways it's done is pair programming. So a couple of developers sitting down, working on a bit of code, and you've always got two brains working on that then. So if somebody makes a mistake, you can just discuss it there and then. Another way of doing code review is to actually use tools, things like GitHub, as we'll see later how we can use it. And you push your code up, somebody looks at it, and then they can make comments on the code as they're going through it. So these are kind of the main ways. Today we're only going to look at the GitHub way of doing code review. I've not really done a huge amount of pair programming, so other people are more equipped to talk about that. So what are the benefits of code review? We've kind of alluded to some of them. It's just we can reduce the number of defects in our code. That's probably the main reason. That's probably what people think of first. You know, we're going to reduce the number of defects we have in our code. And we might also find security vulnerabilities. Arguably, they are defects, but I suppose a different kind of category of problem. Other benefits is we can spread the knowledge between people in the team. So what we can do is if multiple people are reviewing the code, then they all see what other people are doing, which is quite a useful benefit and kind of, you know, you don't get siloed code, which people working on silos, which we'll talk on more later. Then there's the ability to mentor people. Certainly if you've got junior developers working on a project and nobody's ever looking at their code as they write it, how are they going to develop fully? So code review does offer a platform to easily offer some kind of mentoring and advice, and therefore get people up to speed. And the other thing is kind of peer pressure generally does improve code quality. If you know somebody's going to be looking at your code, you often code a bit better, I've found. But we'll talk about that a bit more later. So what are defects? Probably when I say defects, you kind of think of bugs. You kind of think of if this bit of code was actually run under this condition, it would fail. It would crash. It would give the wrong answer. It wouldn't behave correctly. But there's another type of bugs, and these are called evolvability bugs. And evolvability defects is code that makes the code base less compliant with standards, more error-prone, or more difficult to modify, extend, or understand. And the interesting thing is, is kind of the proportion when you're doing code review in what these are. Maybe 60–70% of your bugs are evolvability bugs or defects, not actually bugs as in traditional bugs, which you're probably thinking of, things that actually will stop the software from working. And the interesting thing about that is even if we had perfect tests and we got rid of all, great static analysis, and we got rid of all of our bugs, there's still, as in these bugs, there's still all these evolvability issues or defects in our code base. And I've been doing code review, as I said, for about 7 years now, and I kind of agree with this kind of proportion. You know, if anything, evolvability bugs are the majority, like even more than 60–70%. And there's been some papers that have looked into it. And why evolvability defects are an issue is because they cost money. So there's been some academic papers. I've referenced them here. The end slide has references if you want to go back to look at the papers. But one paper found that features took 28% longer to implement on low evolvability code. So you're taking an extra quarter of your time to develop new features because your code isn't very well structured or isn't very clean or isn't open to evolution. They also said fixing bugs could take as much as 36% longer, so over a third longer, because our code base isn't very well designed. And another paper was looking into it, and they say software structure probably accounts for 25% of the total maintenance cost of an ongoing project. So, and again, we're probably, if we've been on any long-running projects, we probably have kind of seen these things. Maybe we haven't quantified it, but we've probably seen these kind of things. So if we imagine the cost versus the time, so the cost is how much to produce a similar sized bit of functionality, and the time is how far we are into the project. And generally, we probably find that the further into the project we go, the longer it seems to take to do the same size chunks of work that we had previously. I don't know if people have experienced that on long-running projects. You know, it's just, why is this taking so long? You know, it's like we're running through treacle or running on sand or something. It's just not taking, you know, it shouldn't be this long. But of course, if we do things reasonably well and we design our code base well, then actually it's more like the green things. Yeah, there's a slowly over time, it's taking a bit longer to develop you know, similar sized chunks of functionality, but essentially it's staying reasonably constant. So this is really important. It's harder sometimes to sell, you know, essentially refactoring and making the code clean because it's not as obvious at the time as to how much that really is impacting on the cost of developing software. But there is a cost there. Papers have studied this, and this is why it's really important to do these things. Another reason why we might not find as many traditional bugs in code review as you might first imagine is if we're running code review along with tests. What we're probably doing is we're looking at the tests and going, hang on a minute, this test doesn't test everything it's supposed to test. So the code review will look at the test and go, that's wrong, you need to go and do more with this test. And the author goes away and they add some more to the test code. And of course, they find a bug, they fix it, and the person doing the review might not even note that as a defect found. So we've got our test here, you know, we're going into the cave, we're coming up to a T-junction, and before I pass the T-junction, I must drop a cookie. But of course, that is not a complete test. You know, we're missing something really critical. We have to drop the cookie on the exit side. Otherwise, we don't know where the way out is. So if I saw the equivalent of that in a code base, I'd say, hang on a minute, that test is not complete. We need to have additional information on here. And the author would go away, check the code, add that into the test may pass, the test may fail. If the test fails, they're going to go and modify the code such that the test passes. So again, it's not as obvious that you've actually picked up a defect because you're doing testing and because you're reviewing the tests as well. So this is quite an important takeaway, I think. When people start thinking about code review, they often think we're just finding like defects or actually stop the code working. In reality, probably most of the comments will not be those kind of bugs. They will actually be things about how we can improve the code. But that is important because it does lower the overall cost of development of the code. And this is also quite important to note because if we have to sell this concept to management, make sure we're collecting the right metrics to prove that code review is worth it. If they say, well, we're introducing this code review process and it's taking a bit longer, how many bugs you're finding, and you're only reporting essentially 20% of the bugs, it's not going to look as impressive as if we actually capture the defects for everything. So it is important to note this. And of course, when you start doing code review, you might think, why am I not finding any bugs? And this is kind of the reason. So the other thing we might find when we're doing code review is security vulnerabilities. That's what we should be looking for in our code. So it might be something as simple as their computer has been hacked or whatever, and there's something on there that shouldn't live. Maybe somebody's trying to put some malware up into their Git repo. Maybe they didn't even know it exists. So that's a nice safety check. If you're looking through code and you see, what is this file? That doesn't make sense to me. Definitely question it because maybe it's not supposed to be there. Another kind of bug, that I've actually seen in code review is you might see somebody and they're outputting sensitive information to log files. Maybe when somebody doesn't log in, they're saying, writing to log files, so-and-so didn't log in, here's their username, here's their password. We don't want to be doing that kind of stuff. So make sure that when you're looking through the code, that we're not doing anything a bit silly like that. There's also the whole OWASP top 10 security bugs. And if you want to find out more about that, then come along in 2 weeks' time to the Bristol edition of this, and you can learn all about it. But some of these things can be picked up by manual inspection of the code. And there might be other things like people aren't storing passwords as hashes, or they're using some weak password hashing things. So have a look at what they're doing. Generally, anything around security, you shouldn't be rolling your own stuff. You should be using packages that already exist. And if you're using frameworks, then generally they've kind of got a lot of this stuff sorted. So make sure that people are actually using like the framework implementation of things, or they're using actual packages written by security experts rather than people just coming up with their own thing. So as we've kind of talked, I kind of mentioned it in the introduction, one of the other big gains from code review is you're spreading the knowledge. So even if I'm just working on this section of the code predominantly, I've still got an idea what other people are doing over here and over there. And that's really useful because maybe I'll see things that they're doing. I go, oh, hang on a minute, I've written something that does something very similar. Maybe we need to pull that code out and write some common code that solves both our problems. But just the knowledge of what's going on has a lot of benefits in the fact that people aren't working in silos anymore. We haven't got like Jane's bit of code here and like Bob's bit of code over here. Jane and Bob know what's going on. So we don't really want to be working in silos. And the great thing about everyone kind of sharing the responsibility for the code and everyone having an understanding of the code is it means Jane can go on holiday and she doesn't have to worry about being phoned up because everyone else knows what's going on in the code. So people can actually have some real time out from whatever project they're working on and know that it's just 2 weeks off without interruption. Then there's the bus factor. Does everyone know what the bus factor is? Yeah. So the bus factor is how many people have to get run over by a bus before your project is in serious trouble. So if you have a bus factor of 1, that means if something happens to that one person, potentially a whole business isn't viable anymore. So another benefit of code review and sharing the knowledge and spreading the knowledge is you've got a bus factor hopefully of at least 2, hopefully even more than that. So yeah, I mean that is actually a really important business requirement as well. And you might think, why is he going on so much about business requirements rather than the code things? It's because this is what's important. You know, if you're developing code commercially, then actually one of the most important things is, you know, are you doing it at a reasonable rate? You know, are you developing code cheaply enough? Another great thing in code review is it helps mentor people. So people might think that is senior developers helping out junior developers, and that does happen a lot. But there are other benefits as well. It could be you have relatively junior developers, but they've been on the project for a while, so they know the project quite well, they know how things are done, they know where bits of code are. And then you might have someone who's a relatively experienced developer, but they are completely new to the project. So you can kind of help them get up to speed as well. And if you kind of think of a graph that shows kind of skill and experience versus how many bugs you introduce, the longer you've been on the project, your rate of introducing bugs will kind of decrease. And this kind of mentoring and sharing of knowledge means that it gets people up to speed quickly. More quickly than if people had done, you know, hadn't had the benefit of this kind of stuff. And the fact that you know somebody is actually going to be reviewing your code, I mean, probably someone will always read your code eventually, but the fact that you know somebody's actually reading your code in the next day or 2 does modify your behavior. You do generally write better code. And I've kind of noticed this on projects where we've introduced code review, that it does seem all of a sudden that the quality of code takes a bit of a jump in upwards. But this is all anecdotal, and the plural of anecdotes, unfortunately, isn't data. Now, the closest thing I could find that was a bit like this is last year, or 2016 actually, some UK police forces, and I think they replicated it in studies around the world, started having cameras on. So the police had cameras on them, and they then compared the number of complaints against the police versus the same time in the previous year, and they only had 7% of the number of complaints. So just being watched generally changes people's behaviour, and in the case of code review, I think for the better. So that's kind of a summary of the benefits we've discussed, and hopefully you are on board that this is a good thing to be doing. So that's great, you're on board. How are we going to implement all this information, all these things? First thing is code review should only be focused on things that you cannot automate. If there's anything you can automate, it should be automated, and then it's your continuous integration server, something like a Jenkins server or Circle CI or Travis. And what they do is every time you push up some new code, they go and grab the code down and they run their checks. So they'll do things like they'll run all the tests and check they all pass. They'll run things that check the coding style adheres to whatever standards we've set for the project. They can do things like linting, so to check what you know is valid, and it's not just PHP. You can have linters for YAML and Twig and Doctrine, and you can even do composer validate to check that your composer file is valid, and you know the .loc file and the JSON file are in step with each other. You can do kinds of static analysis, where that looks more in your code in more depth and will find errors and problems. And there's things like you can do third-party security checks. So the Sensio Labs security checker, it looks at your composer JSON file and it checks if there have been any security bugs reported on the packages you're using. This we can all automate, and anything where you can pass it your code base, it can look at it and it can say with certainty whether it's passed or failed. That is something you should be automating. We shouldn't be wasting human time on stuff like this, because human time is way more expensive than computer time, even when you take into account, it takes a while to set some of these things up. So what are we looking for when we are doing our code review? Probably the most important thing, I think, is, are the tests actually testing what we're supposed to be implementing? And the reason it's often easier to look at the tests is because the tests you're kind of expressing, this is our starting condition, this is what we're doing, this is my expected ending condition. So it's relatively simple code. And you can use things like bhat, and it makes it look even more easy to kind of a human to look at it and go, right, I can understand what we're testing. I can then see what the gaps are, and then I can raise an issue and say, look, I think this test doesn't test everything it's supposed to do. So you're asking, do the tests test the required functionality? You're particularly interested in the happy path. Are things going, are we doing, if people are using the code in the way it's intended to be used, is it behaving correctly? And then you've also got to think about some of the edge cases where people might not be doing things correctly. Have all those things been covered off? Are the tests adequate? So coming back to my example from earlier, if we hadn't got this little extra bit that says we've got to make sure we're dropping the cookie on the exit side, that test wouldn't be adequate. It doesn't actually fully check all the things we need to be doing. So that is really, really important. And when we're looking at tests, we can just look at things, if we're down to more like unit test level now, we can look at what we're testing and like how many tests do you think we need for some code like this? What's the absolute minimum we think we can get away with? Anyone got any thoughts on that?
3.
3? Yeah, if I was going to review this, I want to see there's 3 tests. We're checking the ages 17, 18 and 19, and it's given us our correct answers. So, and another one, we've got, if this is the kind of signature for the function, how many tests would we want to have here at absolute minimum? 2, any advances on 2?
I think 3, because you need does it?
Yeah, I'd go with at least 3. So we've got is allowed and returns a Boolean. So we need to do something which makes it return true, something which makes it return false. But we've also said, well, there's a not found exception. So we need to do something that will throw a not found exception. So these are the kind of questions, and this is 3 as a minimum. When we know a bit more about what this is doing, there could be way more tests that we need to be looking at. So, and coverage tools kind of help us inform as to whether we've tested everything we need to, but actually often it's just a human has to look at it and work it all out. So it's really important that we test out that when we're checking our code base, we are checking that our tests are comprehensive enough. Probably the next most important thing to ask ourselves is, will I understand this code in 6 months' time? I often come back to code I've written probably even less than 6 months' time and go, oh, what was I thinking? For many reasons. So this is this is probably the second most important thing. And what we're looking at, does it make sense? And will it make sense later when I've kind of forgotten the context in which I'm working in? I mean, people don't deliberately write bad code, but it just happens by accident. So sometimes people are so focused on what they're doing and they know so much about what they're trying to achieve that they put things down. We'll see some examples of real code that I've either written or reviewed. And you come back to them later and you go, I just don't know what that means. Now, I'd wish I had reviewed this because it looks like there's a mistake. Oh, no, that's right. Yeah. Transition I didn't know was going to happen. And there is a major cost because we spend more of our time reading code than writing code. And if you think about how quickly you can type, especially with modern IDEs, if you could just type away, you'd write thousands of lines of code every day. In reality, you don't write thousands of lines of code. And there have been studies done on this, And what they've done is they've watched people use IDEs, and they've timed how long people have spent looking at things and actually writing code. And I think this is an old study, so maybe modern IDEs kind of improve this slightly, but they're saying it's well over 10 to 1. So we're spending for 10 units of time actually reading code for just 1 unit of time actually writing code. So if we make our code easier to read, it means our overall productivity is going to be quicker. So if we imagine here, we've got our reading, that's 10 units, and our writing is 1 unit. Even if we could write infinitely quick, we've still got 10 units of time. We can't really save that much. But if we wrote our code in such a way that it was much easier, we could understand it twice as quick, then even taking into the fact we've still got to write the code, and even taking into the fact we go through this whole refactor and code review, our overall, we're still better. We can still write code quicker than beforehand. Is everyone kind of happy with that? Okay, so we'll wake up here. What does this code do? Is it obvious? This is real code that I've actually reviewed. Okay, I'll help you out. It actually does the same as this. What does this do? It's basically copying code from user details and putting it into the user object. That functionally is the same as the previous code. Yeah, it's not as clever. It's a bit more boring, but generally with code, boring is good. So if I saw something like this, I'm looking at this, I've got no idea what's going on, and that's something I would pick up. Make it simple. What about this one? So we've got an object called location. It represents a location in the UK, like a city, a town, like Bristol or Bath or Weston-super-Mare or whatever. And one of the things we've got on it is, well, what is a URL for a town or a city? What does get URL return? I don't know. And this was code on a project we worked on, and we look at it and we go, I don't know, what is a URL of Bath or the URL of Bristol? Even things like a person object. What is a name? Is that the first person? Is that the person's first name? Is that their full name? Does it matter if they only give their first name? So what I'm kind of saying here is, you know, if I wanted to really work out what URL is, I'd have to go and look in the database and look actually what these strings were. I might have to then go and visit the website to work out what these strings actually represent. So it's things like this. This is what I mean. Will I understand this in 6 months' time? I don't think I even knew what it was at the time I reviewed it. So we're never going to know what it is in 6 months' time. And I challenge everyone, go back to some code they've written, look at a get method where it says something like get name or get URL or whatever, and ask yourself, do you really know what that is going to return? And if you don't know what it's going to return, you need a comment on there to tell you what it's going to return. You know, it takes a minute to write a comment.
Comment?
Sorry?
You think comment?
Sorry?
You think the comment is the right idea? Because I think comment will be another form of documentation which is not connected directly to the code.
Well, okay, if you could name it in such a way that it made it really obvious what it was going on, but you'll still, I think, even when I think I've documented it really well, I mean, if my comment just says the same thing, if my comment was get URL, clearly that's not a very good comment. But actually, it might say, if this was a URL of, I don't know, a Wikipedia entry or something like that, you could just put that in as a comment. I mean, maybe you could change. I mean, I agree with you. You should be trying to make the code in such a way that you kind of don't need to look at the comments, but the comments are the next best thing. I mean, it's better a comment than having to look in a database or read through the code to work out what's going on. So another example, here's some code. What does one mean? I don't know. So if I was reviewing this, I'd say, well, look, we clearly need a constant for whatever one is, just to give some more meaning to it. So these are the kind of things, and this is all about understanding and comprehension of code. So next question is, are we following project conventions for naming of stuff, for example? So if we look at this interface, is anything a bit odd there? what about this one? All the others are find, 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 and then suddenly we've got search for location. Why is it not find location? You know, it doesn't seem to fit with everything. So whatever common language you're using to find something or get something, just use it consistently. And this is one thing we actually start doing is, like, when you start doing code review, if you haven't done it before, what you'll probably find is you start getting into lots of conversations like this. Are we finding something? Are we getting something? Are we searching for something? What is our common terminology? So discuss it somewhere. It doesn't have to be in a Slack channel. In fact, there are advantages in not using a Slack channel, because once you've had 1,000 messages or 10,000 messages, you then can't go back to these important decisions which we should have documented elsewhere. So maybe discuss it in one place and then move it somewhere like a Google Doc. And this is something you'll find if you're introducing code review. You'll have lots of these discussions, document them so you remember what conclusions you came to. And what we kind of used here was threading. So we'd say, you know, this bit would say we're not going to use abbreviations, and then there was a bit of discussion about why we weren't going to use abbreviations. And then if you ever want to go back to work out why we don't use abbreviations, you can just go and look at the thread. So something similar to this. Whatever you do it, however you document it, the tools are not important, but you'll probably need this kind of stuff when you start doing code review. So coming back to the point you kind of raised, is your code as obvious and explicit as it can be? So can we make this thing more obvious? We've got this marketing campaign, and we've got a method which is add address. So what is an address we're adding? Okay, we can make it more obvious. We could say it's an email address. And then we could add something, a comment there, and I think this adds, we're just not adding an email address, but we're saying we're adding it to the marketing campaign, and at some stage later, we're going to email all these people. So this is something where maybe the comment adds more than you could really have in a sensibly named function name, method name. But we could go further. We could say, well, let's type hints. Let's tell you what parameters we're using, what we're returning. And arguably, if we're using email address all over the place, then maybe we should have a value object. So an object that represents the email address rather than a string. So these are the kind of things we're looking at, make our code really, really obvious. And then ideally, when we're writing code, I think there's 2 times we should look at code: when we're writing it and when we're reviewing it. And the rest of the time, it should be obvious from how we've named it and the comments in your code. And the benefit of doing that is if we're working on some code, we've got a marketing campaign, we're adding the email address, and if it's not obvious enough from the function name, in PHP Storm, you can do F1 and it tells you the information, it gives you the comments that you wrote there. So it means we don't have to go in and look at the code. We don't have to start understanding and parsing PHP, because humans are quicker at understanding like language than actually understanding like PHP. And of course, if you start doing all this stuff, then you get all these nice benefits, which is why I think a modern IDE is a central part of the whole code quality thing. You say your marketing campaign, and PHP Storm or whatever your IDE will tell you all the available options that you've got. So it's stopping you, if we've done all those kind of things that I suggested, it's stopping us from introducing mistakes, and it's helping us write our code quicker. So do the comments match the code? This is really important, especially when you've edited a function or a class. You know, you've made an edit to it. Is the comment with it still relevant? Other questions: has defensive coding been used? So what might not be ideal here? We haven't got any default. What if status isn't any of those 3 things? So we could put in a default. These are the kind of comments I pick up. Maybe static analysis tools will also point those issues out as well. Got a function here which we're setting a status, and in the comment we said status is one of started, finished or quit. So we could actually assert that. If I saw this code, I would say we need a check in here to make sure we can only pass in these 3 valid values. Controversial one. Has technical debt been documented? There are times when we have to knowingly introduce technical debt. A real example is a project I was working on. We had to get it out in November because then we got all of the Christmas sales benefit, from it. If we left it till the code was perfect, so a developer would be happy with it, we might not get that out till middle of December. And the opportunity cost is immense. We would have lost so much in sales that even if we put out some slightly dodgy code, even if we then have to compensate people because there was something went wrong, even though the total cost of the code will be more because we put in technical debt, which we then had to take out, from the business as a whole, we're still up. So sometimes you have to put technical debt in, but if you're going to do it, then make sure you document it in the code. And we have a rule, if we're knowingly putting technical debt in, we have a to-do comment, and we have something that links back to whatever ticket documents it, so it's not forgotten about. And of course, if there's a ticket in Jira or Trello or however you document stuff, at least it can be addressed at a later stage. Make sure we're naming things, we're doing things correctly. So if you have whatever domain you're working in, if you have set words for things, and make sure those are the words you use. Don't interchange them with other things. You know, if you have something which in your project means something like an internal retailer is something we've got in our project, that means something very specific. So call everything that's to do with an internal retailer, an internal retailer, and don't call it something else because it just will confuse people later. Likewise, if you're using design patterns, if you've got something that's a factory, call it a factory. Don't call it something else. And if you've got something that is acting as a factory, but you've called it something else, then it may be in review. This may be something where you've got experienced developers looking and go, you know what, that's actually factory, let's rename it to that, because maybe you didn't know what a factory is, but you know now, and other developers will know. Can the architecture be improved? There's lots of things like, are we at the right level of abstraction? Use solid as your guideline here. And finally, are there any bugs? There we go. That's probably what you thought you'd be doing, but actually there's loads of other things that probably will be doing. So that's our big long checklist of stuff. But if you want a shorter version, it's like check the tests are correct, make sure the code is clean, and make sure you can't find any bugs.
May I have one question?
Yeah.
Don't you think that one should be at the very beginning of the code review?
Which one? No bugs?
The testing, the bugs and that. Basically, like at the beginning of the code review, you should like run the test suite and check.
Yeah, so I'm assuming, well, we can't come on to this, but I'm assuming that by the time we're doing code review, all our automated tests have passed. We come on to that bit there. So here's some tips. Who should do the code review? You want to get everyone involved in code review because it's beneficial to everyone. Sometimes, generally, the more experienced you are, the more likely you are to pick up some of these issues. So we used to have kind of a rule that someone would review the code, but if they thought it's quite a big chunk of code or they didn't really understand it, they would ask someone else to do it as well. It kind of depends how big your team is. And we want our code to be, we want the stuff we're reviewing to be relatively small, because if you ask a programmer to review 10 lines of code, they'll probably find 10 issues. But if you ask them to review 500 lines of code, they'll probably just say, no, that's great, go on, get it out there. So we want small commits. Our ideal thing would be just a single really small commit, but sometimes you're writing features that you can't fit in a single small commit, so we break them into several commits. Each of those commits should be small, and let the commits kind of tell you a story. So, you know, we're going to deprecate something, then we're going to add some functionality to it, and then we're going to refactor our code, and then we're going to remove the stuff we've deprecated. So when you're going along, you can look at it and go, well, that's what we're doing, that's what we're doing, that's what we're doing. Ah, great. So it's kind of like the commits of a story. Git rebase, interactive rebase helps you out here. So some studies that were looking about how much code you can review in one go. SmartBear did a study on looking at a review done by Cisco engineers, and they said fewer than 400 lines of code at a time. Once beyond there, you kind of really dropped off in how many defects you found. Keep it under 500 lines per review per an hour, and don't spend more than an hour actually doing review. And that was them looking at the reviews from lots and lots of people, so they took a big set of data there. So we kind of said good commits are small. They kind of focus on one thing. It's a bit like the same advice you give for a class. or a function, small, focus on one thing. If you've got a commit full of white space changes, then just do that as a single commit. Don't have anything else in there. We also say, like, put your composer on updates into a single commit, because otherwise that big composer lock file just gets in the way. So put that in one commit. And what are kind of good review comments? So you've seen something you don't like. The first thing is basically, don't be an idiot. Don't be rude. Just don't be critical of the author, even if they've done that a few times. You don't know. Just say, this is the issue. We'll focus on what the issue is. Don't be rude about the author. So state the problem and give a solution. Like someone saying, I don't like the name of this, isn't particularly helpful. Like the author probably didn't like the name of it, but at least suggest maybe a better name. And then you can have a think about it, and maybe you'll come up with an even better name. Link to stuff. And don't spend, like, if you've seen something that neatly illustrates the point you're making, then just link to Stack Overflow or a blog. Don't rewrite it all in the review comment. Just say, it's just like this. Whatever problem you've got, somebody's already done it and documented it, so you can just link off to other stuff to make the review process a bit quicker. Don't be afraid to say things like, let's chat. I look at it and go, I could spend half an hour writing all this down, or let's go and have a chat about it. Sometimes I also use things like where I say, I've got questions. So the implication here is, I'm pretty sure what you're doing is right. I just need to understand this. So I'm not saying something as strong as I think you've got it wrong. I'm saying I think it's my understanding that it's not quite right. But I don't want to let this go. I'm pretty sure there's no action on your part, but I just need to understand what you've done. And if they've done something nice, compliment them. That's always good.
Can I ask something?
Yeah.
So, like, if you have a significant critic to someone, you should go and speak with him directly and say something good to him before you start with the critic.
You could do, yeah. I like your shoes, by the way, your code.
Basically, in the GitHub or whatever Confluence, it will basically automatically hit him, and he will be aggressive directly towards you.
Yeah, and that comes back to the first point. Be nice, don't be rude. So if you're kind of receiving comments, again, try not to be rude back. But also, don't take offence. You don't give offence, you kind of take offence. You could read it and going, well, we haven't put the comment on again. Or you could go, actually, I haven't put the comment there. That's a valid point. I'll put a comment on this thing. So try not to take offence. But also, if you disagree with what they've written, then say, actually, I think you've misunderstood. I believe this is it. And it might start a conversation. And the result of that conversation is both of you have a much clearer idea of what's going on. And say, I'm glad you spotted that. That's a good spot. So, be nice. So our kind of tips for this, get everyone involved, keep the commit small, and be constructive in your code review. So this all sounds great. You know what you're going to do. How do we implement this in? We want to start it tomorrow, hopefully. There's lots of ways of doing this. We're going to look at one simple branching strategy, which is called the pull request. But before we do that, what we're trying to achieve, and it doesn't really matter how we achieve it, but we want to make sure that code can only be deployed to a live system if this is what somebody mentioned. If all our continuous integration stuff passes, all of our tests pass, everything else, and the code review passes. So it's only when these two things happen can that code be deployed. And ideally, only people are working on code which has also had, apart from the stuff you're working on, but other people won't be working on your code until the CI passes and the code review has passed. So we've got these things called pull requests, which are quite common in things like GitHub and Bitbucket and open source projects generally. We've got our master branch, and then we want to create a new feature. So the master branch is existing code that's already there, already been signed off. Then we're working on our own little feature. It's a few commits, and eventually we're done, and we ask someone, we make a pull request, and then somebody goes and reviews it. And they say, yeah, I'm happy with that. And at that point, it is safe to merge back into master. So this green dot here, that's our final commit in the feature branch. CI passes, everyone's happy. So we merge it back into the master, and there we go, it's part of the code base. What might happen is something goes wrong, code fails, review fails, and then we cannot possibly merge that back in because something is not right. So instead, we have to fix it, and then once we've fixed it and we've got sign off, we can then merge it back into the branch that everyone else can then use. So imagine we're working along and we've got our green tick, and we're ready to merge back, but in the meantime, someone else has also done some code and they've beaten us to it. It's not, even though we know this works, we don't know that the combination of our code and what somebody else has just done works, so it's not safe to do this. Instead, we need to merge the current master branch into ours, and then providing that's a green tick, we can then merge it all in. So that's a really simple branching strategy. There are a lot more complicated ones. There's, but if you're a small team or you're just getting started, then something like this is probably quite good. There's Git flow, is a lot more complicated than this. So how are we going to set this all up? It's really easy. Let's just imagine we're using GitHub. The tools are not important. I just use GitHub because probably most of us have used it in the past, or maybe using it now. So we basically go into settings and we go into branches, and then what we're going to do is we're going to basically say, I'm going to choose a protected branch. So let's say it's master. We're going to say we cannot merge into master unless our continuous integration is passed and everyone signed everything off in code review. So we do that, and then it will give us some options. So we say we're protecting this particular branch. So we tick that box, and then we're saying this is the important one. So we're requiring that somebody else has reviewed that code and they have signed it off. And if they've done all that, then it will be in a safe state to merge. That's one of the requirements for merging. The other thing is, if somebody said it's all okay, and then you push up some more code, then we don't know it's okay anymore. So you tick the box to say dismiss stale pull requests. You still need approval again. GitHub is quite nice in that if you've already reviewed some code, it remembers that and it just shows you the new stuff. You can require status checks to pass before merging. So this is things like our continuous integration. When you first set this up, it might say there aren't any status checks, and only after you've run, they've missed one here, oh God. The other thing is, another quite important one, require that branches are up to date before merging. So that's that final example, okay? You can't merge anything in unless the thing you're merging in is based on master. Based off the current master. So let's say we've run Circle CI or Jenkins. Once you run it for the first time, you'll then get a tick box which you can tick to say that's also a requirement for signing off on the code. So we've seen that integrating code review into project workflow, you need some kind of branching strategy, and we've looked at a really simple one here. It's really easy to do. You can set that kind of thing up in GitHub in no time at all. So in some respects, there's no real excuse for not starting. Whatever tool you've got for managing your code, there probably is some kind of review thing. Like Bitbucket is very similar to this, and no doubt there are others as well. So we've covered quite a lot. Hopefully I've convinced you of the value of code review. We've looked at the kind of things that we need to do in it, and we've seen how we can implement it and some kind of tips that I've picked up on the way. And finally, we saw just how easy it was to integrate into your workflow process, especially if you're using things like GitHub or Bitbucket already. So the headline thing is code review done well will reduce your costs. You'll have fewer bugs. You'll have cleaner code, which means that your total cost of development is less in the long run. We've got benefits that you can quickly skill people up. And the tools that are available today make this really, really easy. And our kind of review checklist is we're looking for security problems, we're looking for the correct tests, we're looking for clean code, and we're looking for bugs. That's what we're looking for. Right. Any questions on any of that? Yeah.
Is there a point at which you should just accept something if it keeps coming in and out of code review?
So you mean two people just arguing about that, about something?
They change something and they do it wrong every time.
Well, okay, if they keep changing it to do wrong and you're just not happy, you could even download the fix and push up the fix and say, this is what I mean. And sometimes I have done that, like I've said, can we improve this comment here? And they've kind of improved it, and I've gone, I'll just do what I think is right. And then I push it back up and say, are you happy with this? And they go, oh yeah, no, I'm happy with that. Or there'll be some more discussion. I mean, ultimately, you probably need someone who's ultimately responsible for making the technical decision. And if you've got two people arguing, that's their job to say, no, we're gonna go this way, because you can't discuss things forever. So you've got to get code out. But I think generally, if you've got people who are reasonably sensible, you come to some sensible consensus in the end. Yeah.
I'm curious to know what sort of percentage of time you think should be spent on code review, but compared to the original amount of time spent doing the work.
So I think something that I've taken, say, a day on, it might take someone 10, 20 minutes, half an hour to review. And I think it's almost always worthwhile in terms of the fact they understand what's going on. So I could then get hit by a bus and life continues. But also, they often find things as well, or we often discuss something and then we have a better understanding of what's going on. So I've come from working a very siloed bit, and then someone else is going on the code, and it's kind of a lot more shared.
Yeah, I think what we found, or I've found personally, is when I'm being asked to review something cold, if it just comes in as a little link to a GitHub pull request, it's in danger of taking quite a lot longer than that as a percentage of the original time. Seems to be quite good to start off with a sort of one-to-one with the person, as in explain to me briefly what you were doing, what's it all about, what are the main files, and then go do code review. Then it cuts it down a lot.
Yeah, I mean, I suppose if you're both working on the same project, there might be a bit more awareness of it. But if they're working on something that's either a different project or so different to what you're doing, then I think that's kind of a definite benefit. Other things is if you can put links in the when you create a pull request, you've often got a little box you can put things in. So actually reference whatever, the Jira card, the Trello card, the story that you're working on. I mean, the hope is that should be descriptive enough to at least understand what's kind of going on there. But yeah, good point. I think this might have to be my last. Yeah. No pressure. All right, you can have two questions. Yeah, you can have two questions.
The first question is, how lenient should you be on juniors? So you get, say a whole file has been changed or created, and there are a good, say, 7 things that are wrong, ranging from comments to something that's broken. Would you prioritize, or would you?
So the question is, well, it doesn't necessarily have to be juniors. If you've got a code review where there's lots wrong with it, what would you do? So there's a few things. You can try and encourage people to start the code review process earlier. So if you've got someone who's consistently coming back with lots of review points, then maybe ask them to open their pull request earlier, and they just put a comment in saying this is not ready to merge. So you've always got that outstanding issue. And then you can start picking up these things earlier in the hope that you don't get too far along the wrong path. So that's one thing I would do. Again, I mean, this is a lot prevention rather than cure. Get them to discuss it with you first. So we say, right, before you start that story, let's have a chat about how you're going to go about it, and you kind of do a whiteboard session. But let's say it's all done. It kind of depends probably how imminent the deadline is. You're always going to be better off tidying this stuff off the sooner you get to it. But in real life, you've just got to get something out the door, and you might have to go, all right, we're just going to have to do things that are actually really critical. Everything else we'll leave in there. Great if we could just put a to-do and a little Trello card saying we need to clean this up. And then at least it's it's noted, and project management can decide how important that really is. But yeah, is that me done?
I found that if you start becoming too lenient, it leads to bad habits. Oh, you let me off that last time, why is it a problem this time? And actually, especially with developers earlier on, I think you need to be softer in how you approach it, almost firm and strict in what you're reviewing to get those standards up. So you, you sort of need to be softer in approach, but stricter on what you're reviewing a little bit, I found, because otherwise it really is a bad habit.
I like that.
You consider that some, let's say, you have like few stages of that review, and you consider that at one point you basically fail that review completely and don't follow the next steps until that.
You also say.
Let's say you start reviewing some code,
Yeah.
and you may reach to the point where you reckon that there is a problem which needs to be solved before you gonna continue that review.
Yeah, so I suppose the question is, if you've got a review and you notice something, like you're at file 2 of 50, and there's something critical in there, yeah, I'd probably stop and discuss it. That would probably be a let's chat, and we'll just go through what's happened there. I mean, the hope is the more that people are doing this stuff, the less chance they will be in these situations. And if you've got people that are new to a project or new to it, ideally, and you can't always do this, you'd encourage them off to do little bits first, just to get them into it, to try and prevent those kind of issues from happening. But yeah, and just talk early, you know, just chat about it early before. I mean, prevention is always better than cure in this case. I think, oh no, one more? Oh yeah, sorry, you did, didn't you?
I actually thought of 3 more, but that's fine.
One more.
Yeah. Do you review commit messages?
Yes, I might not necessarily pick up on like typos in a commit message. But one thing we do try and do is at the start of it, just say what it is. Is it, are we deprecating it? Are we doing something new? So they always start in capitals: deprecate, new, update, refactor. And if the commit message doesn't really have any relevance to what we're doing, it kind of depends on the situation. I might just ask, well, what's going on here? Because I suppose once you've got past that review stage, you're never really going to go back to it, because once you've merged it in, you've kind of like, it's done. But again, I mean, I'm fortunate at the moment. I'm working with somebody who's pretty sharp most of the time. So, you know, generally everything is done pretty well. But what normally happens in these things, like in the early days, somebody starts doing things and say, I think this is how we want to standardize on this project. And, you know, on the Slack discussion about how we mark things, then we're going to say this is how we start with, this is the format of our commit messages, which is always useful, because if you want to automatically pull things out later for like what's in this release, yeah, so you might pick up on things like that. But I'm pretty lucky at the moment. We generally do things okay. Okay, and you can now review my talk. That'd be great, thanks.